So here we've got a question involving a right angle triangle, and it's asking us to work out the length of one side and knowing the length of two other sides. So it's kind of shouting out, please use Pythagoras. So again, we write out the theorem and the little picture to go with it to remind us that A and B are the lengths of the short sides and C is the length of the hypotenuse, the longest side of the right angle triangle. Remember, it's important to do this, guys, because the triangle could be in any orientation, and we need to remember that the C is always opposite the right angle, and it's the longest side of the right angle triangle called the hypotenuse. So we've got the theorem written down, so let's identify the values we've got. So A, B and C. So A is worth 6 centimetres, B we don't know, and C is worth 9 centimetres. So we follow the theorem. So A, replace it with 6 squared, B, replace it with, we can't, we don't know it, and C, replace it with the 9, so 9 squared. So B squared is going to equal 9 squared, take away 6 squared, because this was positive, so to make it 0 we're going to take it away, but we must do the same to both sides, so 9 squared take away 6 squared. So B squared is going to be 81 take away 36, which is going to be 45, and B squared then tells us we want B. Move things by opposite operations, inverse operations, so the opposite of squaring is square rooting, so B equals the square root of 45. Now if the exam question said leave this in surd form and so forth, then that would be left as it is, the root of 45. We don't need to, oh well, we could recognise, if we want to be really good, that a square number goes in there, so it's the same as doing the root of 9 times the root of 5, so it'll be 3 root 5. But this question said it wanted it as 3 significant figures, so we're going to get our calculator and we're going to put in the root of 45 equals, so to 3 significant figures, 6.71. We want 3 digits. We start with the first non-zero digit, 6, count along, 7 is the second significant figure, the 0 is the third significant place value, but the 8 thousandths is more than halfway of a hundredth, so it goes up to 1, so it's 6.71 units, centimetres. And then just to show that the other one works, 3 times the root of 5 equals, and again we get the same answer, 6.71. So either way we get the answer correct at 6.71. So a little bit of Pythagoras. Key thing is write down the formula, the theorem, write down the picture so that you can see, I'll draw the picture shall I say, so that you can see where the A, B, C are to remind yourselves, find the numbers, put them into the rule and then work it through, remembering B squared, we need the B, we opposite of squaring, square rooting.